Hi guys, this is Calculus video 5-7 for Wednesday, January 11th, and if you're watching this on Wednesday, January 11th, happy snow day. I just woke up and it's 11, so that's a good start to the day. There's going to be no homework that corresponds to this, but there will be a quiz tomorrow on finding antiderivatives. And if you're in physics, you already know how to do this because we're going to use the reverse of the power rule. But I'm just going to ask you not to do it super different than you do it in physics, but we're going to set it up a little bit differently. Okay, and you'll see how. Now, this lesson, before I show you the power rule for finding an antiderivative, which is just like the backwards of finding a derivative, the reverse of it, we're going to learn the average value formula. So average value of a function is the average y value for the function over a certain interval. Okay, so it's the average of all the y values over an interval. And the reason why this is not so easy to find is because there are going to be, for a continuous function, there's going to be infinitely many y values. So how do you take the average of an infinite number of values? It's not as easy as just adding them all up and dividing, because if you want to take the average of two numbers, you'd add them and divide by 2. 3 numbers, you'd add them and divide by 3. 4 numbers, add and divide by 4. But we're going to find the average of infinitely many numbers, and you can't just divide by infinity. You can't just add up infinitely many things and divide by infinity. It doesn't work like that. So we're going to use this formula instead. So f, and then this just stands for average. So the average value of f is equal to 1 over b minus a. That's 1 over the length of the interval, because the interval's from a to b. And then the integral from a to b of f of x dx. And conceptually what this means, guys, is you take the area underneath the function on that interval and you divide by the length of the interval. So that happens to be how you find the average y value. And I'll show you what this looks like visually for a moment, but then I was just having a rough time with it. I don't know. I like to see like proofs of things. So I did write out, okay, average value, average function value, average of all y values within an interval. If you just look here, you don't have to write this down, but I did like kind of a little proof of it. So I, and then down at the end, I end up deriving the formula. So if anyone would like me to post another video on that, because if you'd like me to explain that, I can, or just come see me. I'll bring this with me to school and you can come see me. But I felt a lot better once I actually proved the formula or derived it for myself. Okay, so just what does this look like visually? Because maybe you'll have to estimate the average y value from a graph. So here's an example. Here we've got the graph. It goes like this. And there's infinitely many y values, okay? And I want to know the average value of them. So a way that you would do this graphically is you would take a horizontal line. Well, let me say this first. The highest y value is 5. The lowest y value is 3. So you might say, oh, we'll just average the highest and lowest y value. So the average of 5 and 4 is, or average of 5 and 3 is 4. So you might think that 4 is the average y value. But that doesn't make any sense because there's way more y values of 5 than there are y values below 4. There's way more y values above 4 than there are y values below 4. So the average couldn't be 4 because the y values above 4, there's way more of them. So those would like tip the average higher than 4. So anyway, the way that you do it is you find a horizontal line so that okay, so let me do it this way. So let's suppose I think that the average y value is 4. So I'll do a horizontal line at 4. And I'm going to color the area between, let me make sure this is, I'm coloring the area between my horizontal line and the graph, but above it, I'm coloring that red. And I'm coloring this area bounded by the horizontal line, and below it, sorry, I just woke up. I'm coloring that green. And you will know that you are pretty close to finding the average Y value if the red area and the green area are equal. And as you can see here, guys, this red area is much bigger than the green area. Okay, so that doesn't work. All right, so you color the area bounded by the graph and the line above, and bounded by the graph and the line and below, and then you're trying to get them to balance. So I have to move up more. Okay, so I'll move like up there, and then I'll color that red, and then I'll color this green. That looks closer. I don't know, but I still kind of feel like there's the red area is greater than the green area. So I'll just try one more. I'll move even closer. Maybe this will be too small. I'm not a real visual person, so some of you might be seeing this better than I am. Okay, so now there's the red area, and there's the green area. It looks to me like it's balancing more there. So the average Y value of all of the Y values here it's pretty close to 5. It's maybe like 4 point. So I'll say this. I'll say let's draw like a line like there, and then I'll say the average function value here is about, I'll say 4.7. Okay, now let's do one more. This is a little bit harder. And these, by the way, I got these from Mr. Romer's old packet. So he used to do, I think, a similar demonstration. Okay, so here we've got infinitely many Y values, and we want their average. All right, so I'm going to use a horizontal line, and I'm going to try to make it so the area bounded by the curve and the line above the line, and the area bounded by the curve and the line below the line, that those areas balance out. So let me just try, I'll try 3. Let me try 3. All right, so I'll color, so, oh no, it's not writing now. It dried out already. Crap, and I don't have any more. How did it dry out so fast? Okay, so that's better. All right, so here's this. Okay, so there's the area bounded by the graph and the line above the line. And here's the area bounded by the graph and the line below the line. So definitely we don't have a balance there. Way more red. So I'm going to have to move this up. I'll move it like up there. Okay. All right, so here's red. And green. That looks better. That looks better. I feel like there's a little bit more green, but it's more accurate anyway. So, I don't know, maybe 3 would have been good. I don't know, but let's just say like 3.1. So the average value of the function here is about, I'll say 3.2. All right, so that's what it looks like visually. Now let's use the formula. So find the average value of this function over that interval. All right, so anytime that you're asked to find average value, I would first write the formula down. Okay, it's going to be 1 over b minus a, the integral from a to b, f of x dx. We need to have this memorized. The sooner the better. So that's the average value formula. And then I'm just going to plug in. So b minus a is 6 minus negative 2. So we've got the average value here is 1 over 6 minus negative 2 is 8. And then the integral from negative 2 to 6 of x to the second minus 3x plus 1 dx. in future, guys, you can do this by hand, but right now I haven't taught you how to compute definite integrals by hand yet, so you'll have to use Math 9. So I go here, and I just go Math 9, and then from -2 to 6, and then I'm plugging in the function. Okay. But then there's the 1/8 out front, so I've got to divide by 8. And I get that. And since I have this 0.333 repeating, I'm pretty sure that's a fraction, so I'm just going to, I just wanted a fractional answer. So 13/3. So I don't have to round. Okay, so that's the average value. So let me just do a little demo here, okay, of what that looks like visually, and then we'll learn how to take antiderivatives. All right, and you could go fast through this if you want. I'm not asking you to do this with me. Just watch. So x squared minus 3x plus 1. All right, now I'm going to adjust my window to my interval. So -2 to 6. Okay, y min. I'll do. Leave that y min. Okay, so I guess I want the y min lower. Okay, and I figured out that the average value was, 13/3 it was. My bad, 13/3. So let me graph that horizontal line. Okay, and the area, so there's the horizontal line, and the area bounded by the graph, that's probably, I'm not going to try to color on that, but if I colored in this area red and that area green, the red and the green would be equal. The red area and the green area would be equal. So this here's the average y value of all of those y values. Okay. Now, over here, we are going to learn the power rule for antiderivatives. Okay, this will be fun. So I'm going to split this because first let's review the power rule for derivatives. All right, so over here, power rule, so the power rule for antiderivatives we'll have over here. And then we'll say for derivatives, the power rule is this, remember. If f of x equals ax to the n, then f prime of x equals, you just carry down the constant out front, and then the derivative of x to the n is nx to the n minus 1. So you'd end up in the end with f of x being a times n x to the n minus 1. Okay? For antiderivatives, it's this. So we're going to go backwards. So I'm going to say if g prime of x is equal to ax to the n. So this time, ax to the n is the derivative, and we're going to go backwards. Then, going backwards, g of x is equal to, same as before, you bring down the constant out front. Any constant multiple just comes down. And then you add 1 to the numerator, or not the numerator, the exponent. You add 1 to the exponent and then divide by it. So it's going to be x plus 1, or sorry, n plus 1 over n plus 1. So that's how this works. So we're going to have g of x in the end being a over n plus 1 x to the n plus 1. And then give this a shot. If you took the derivative of this, you'd have to move the n plus 1 out front, which would make it cancel with that denominator, and then you'd have to subtract 1, so you'd end up back at the beginning. Okay, so we have to know that formula by heart. Alrighty, so let's just do a few examples we're going to do examples 1, 4, and 9. All right, so we'll do 1, 4, and 9. Okay. And I'm going to change, so we're going to find the antiderivative of each function, and we're going to be using the power rule. And let's cross off these directions that say express your answer is that. And I'd like you to do this instead. I'd like you at the beginning to always let, and we won't have to do this for long, physics people. I know you're probably already pretty good at this. So at first I'd like you to let f of x equal g prime of x. So we're going to be thinking of the original function as a derivative. So this is going to get our mind thinking of it as the derivative of some function. I forgot something. Okay, and express answer as g of x. Darn it. Okay, I'm not going to start this video over, but I forgot something major here. When you do an antiderivative, guys, you have to do I'll talk about this in class, you have to do a plus c at the end. The plus c stands for any constant. Stands for any constant, all right? This plus c is very important because when you find an antiderivative, when you're finding a derivative, you're finding one specific function that will give you the slope of the tangent line at any point that you want. But when you're finding an antiderivative, you're not finding one specific function. You're finding a family of functions, all of which have the same derivative. Okay, so this plus c, this is what makes this not just a single function, but a family of functions. This could be any constant, and all of these functions here would have the same exact derivative. All right, I'll talk about that more in class. I botched that up. So for number 1, okay, so follow me, and I'd like you to do it just like this for a while. Okay, I know that f of x is 6x plus 5, but I'm going to, for my presentation, I'm going to let f of x equal g prime of x. Okay, so I'm thinking of f as the derivative of something. All right, then I've got that g prime of x equals 6x plus 5. All right, and I think that it would help you for using the power rule to just recognize that that is x to the first, and that if you don't have an x at all, you could go x to the 0 if you want. All right. So now I'm using power rule. So I've got g of x equals, I'm bringing down this constant multiple, and then the antiderivative of x to the first, I have to add 1 to the exponent, so I'll have x to the second and then divide by it. Okay, plus I'm bringing down 5. All right, and then I need the antiderivative of x to the 0 using the power rule. So 0 plus 1 is 1, and then divide by 1. And then plus c, because this is a family of functions. C could be 1, 2, 3, 4, 5, 6, 7. C could be any constant. And this would be an antiderivative of what we started with. So I end up in the end with g of x equaling 3x squared plus 5x plus c. And c could be any constant, and if we took the derivative of this, we would end up with that. All right, and let's try it for a second. So take the derivative of this, you'd get 6x plus 5 plus 0, because this just stands for any constant, and we would have what we started with. All right, so there's the first one. Now we're going to skip to number 4. Okay, and I'm going to let f of x equal g prime of x. So g prime of x, I'm going to use the power rule, guys. So just like the derivative power rule, you need to write everything as ax to the n. So I took that denominator and I changed the exponent to a negative and moved it up top. All right. So g of x equals, bring down that constant multiple. That's called the constant multiple rule. There's one for like every operation we do in calculus. And then I'm going to add 1 to the exponent, so I'll have x to the negative 2 and then divide by it, plus c. So g of x equals, I'll have 12 divided by negative 2, so we'll have negative 6 x to the negative 2 plus c. Sorry. Okay, just one more. So for 9, this last one, I'm going to let f of x equal g prime of x. So then g prime of x is x to the 1/2. Okay, just like you're going to use power rule for derivatives, you would convert like this. Same for using power rule for antiderivatives. Okay, so in this case, using the power rule, I would get g of x equals x to the 1/2 plus 1. So 1/2 plus 2/2 is 3/2. And then I'm dividing by 3/2, and then I need the plus c. So g of x equals 2/3, because dividing by a fraction is multiplying by its reciprocal, x to the 3/2 plus c. So there is our family of antiderivatives for radical x. Okay, guys, so there's that. There is no homework that corresponds to this, but I will give a quiz. I will take questions on this process, and I will give a quiz on finding an antiderivative tomorrow. Okay, guys, have a great day. Bye-bye.